Hello everyone, my name is Theodora Nestorova and I'm very honored and excited to share my work with you today at the 2020 Pan American Vocology Association's virtual symposium. I will be presenting my current research in progress, Does Vibrato Define Genre or Vice Versa? A novel approach to stylistic vibrato derivative analysis. Let's start with the definition of vibrato. A well-known phenomenon of the singing voice, but one that still remains relatively unexplored as a quantitative feature, even from the dawn of the first vibrato studies done by Carl Seashore in the 1930s. The illustration on the right-hand side and description on the left show us the various properties of vibrato. This study focuses on half extent, or the degree of excursion from the individual peaks and troughs to a reference midline, shown here in yellow, in order to granularly scrutinize vibrato by using a transformation formula. It's generally accepted that vibrato has changed over decades, but historically, voice researchers have analyzed vibrato with tools that presume a Western classical opera aesthetic, which is applicable only if vibrato is both consistent and persistent, and it disregards stylistic characteristics of other genres. Furthermore, regularity of vibrato is an important feature for any singing voice, and this deserves to receive further scientific attention. So this makes essential a new comprehensive procedure of vibrato evaluation. Based on this previous research, during the first phase of this study presented at the National Opera Association conference earlier this year, the pilot study, poster shown up on the right, showed that vibrato extent seems to vary more than rate across genre, so we needed to delve deeper into this and create a representative and quantifiable system of vibrato parameters. From this, I derived the objectives of this research. I seek to answer the questions: how can we analyze naturally occurring voices that deviate from the expected regularity and invariability? Basically, how do we measure vibrato in the wild? To test and answer these questions, I gathered data and distilled it into 3 groups, shown here in each of the yellow boxes. On the left are the values that we programmed to be as close to ideal as possible. This controlled nominal group emerged with 3 pattern categories: perfect, normal, and irregular. Let's listen to this etalon. The second group in the middle included modeled vibrato samples based on the synthetic archetypes, but sung by a real voice, myself, in isolation. This case study experiment was designed to test how close I can approximate the ideal by a real voice. I captured these while tracking the Audacity waveform. Let's listen to my rendition of a normal vibrato. The third group on the right was comprised of real examples taken from a large collection of recordings from the 1930s to present day of Im Weißen Rössel, or the White Horse Inn. To test the relationships noted, I had 2 subsets in this faction: 2 pitches sung by the same singer, operatic tenor Jonas Kaufmann, from the same piece in 3 different styles, confirmed by professionals in a survey. And the second, 3 different female singers, each a specialist in their respective genre, singing 2 of the same notes in the same piece. Opera, operetta, which can roughly correlate to American musical theater, and Schlager, which is a style of European popular music similar to contemporary commercial music, emerged. Let's hear one of each subcategory. Each of these sample groups was then run through a custom script in the Pratt platform. I played around with the best sampling rate to capture each individual vibrato. Several values were extracted, including mean half extent and standard deviation. For a moment, let's take a look at the existing models. Vocevista 3.4.3 is a great software which has integrated vibrato analysis capabilities. Here are the parameters that Vocevista calculates for perfect synthesized, normal real voice, and irregular vibrato recording. You can see from the values versus the shapes that Vocevista may not be able to give a full picture. It does not include a measure of variability. Yet, it is precisely the variability of vibrato that my presentation is focused on. As I mentioned in my method slide, the first step was to analyze the synthesized vibrato group. On the left-hand side, these are shown, while on the right-hand side on the right was to analyze the real voice vibrato group. Now, these graphs display the data processed by Pratt. The gray sine wave above the data points is the original fundamental frequency vibrato contour F0 of the signal as a reference, while the blue dots underneath display the calculated half extents over time. Now, I was interested in the statistical summaries of the mean half extents. From perfect to irregular, pay attention to the general increase in mean half extent. As expected, the variability has a definite exponential increase in the coefficient of variation, which is here denoted as CV. Now, I chose CV as the measure of variability, which is normalized for the mean to be independent of the mean value, in order to serve a comparison across sample groups. Visibly, in each of these sample shapes, there are no systematic, dramatic, or drastic changes in the extent relationship over time. So these shapes are what I call monophasic. Now we go from artificial, deliberately generated vibrato prototypes to real life. The second view is of the same singer, tenor Jonas Kaufmann, singing two different pitches, C4 on the left, F4 on the right, of the same piece in three different styles. Here again, the fundamental frequency vibrato contour is in gray, and the half extents are in blue underneath it. As you can see from the values, as in the previous group of data, the mean half extents and CV more or less consistently align and accord within each genre. But if you look at the operetta samples, there are some discrepancies. Visually, in the C4 sample on the left, the vibrato has such an irregular shape that both the mean half extent and the CV are biased. Whereas in the F4 sample on the right, the shape is rather well defined, but again, the parameters seem inordinately disparate. So let's zoom in to this operetta sample, which is actually a frequently encountered pattern in many genres. Tracing the shape, we can see that there is a non-vibrant segment with a transition which enters a vibrant component and finally finishes with a non-vibrant tail. It's no longer monophasic. It's bi or even triphasic, multiphasic, if you will. However, this pattern is far from irregular either, so we need to have a completely representative view for its unique shape. Now, it's not appropriate to calculate a single measure of variability on all points, as shown here on the left, because that would be mixing together a conglomeration of the straight tone and vibrato portions. It's more appropriate to separate these parts into segments, as I have done here on the right with color-coded dots, and to calculate the vibrato parameters in each phase. Based on that, I defined the first hypothesis, that pattern matters to convey variability. One way to do that is shown with the curvilinear approximation on the right panel. Another way, suggested by one of my reviewers from the Voice Foundation New Investigator Forum, is a curve fitting. So this hypothesis is subject to my current and future investigations. Let us now take a look at the summary of the coefficient of variation across all vibrato types and genres. The left-hand bar graphs include both synthesized and real voice modeled samples and show that the patterns from perfect to normal to irregular by design increase in variability. Likewise, on the right-hand side, the vibrato variability seems to increase from opera to operetta to Schlager. Now this is now based on 12 total samples. In addition to the previous slide showing 2 pitches from the same singer over 3 styles, the data from the 3 female sex singers singing 2 of the same notes over 3 styles was added to this group. From this, I drew the second qualitative hypothesis that vibrato variability, CV percentage, increases from opera to operetta to Schlager. I realize that this hypothesis is based on a small sample size, so I'm testing it and it's subject to evaluation over a much larger data set, which is what I'm currently pursuing. This brings us to conclusions and next steps. The coefficient of variation is a good indicator for vibrato variability and seems to distinguish genre within basic, simple vibrato pattern shapes, monophasic ones. However, the CV alone may be misleading in analyzing vibrato variability within more complex, multiphasic patterns. So we need a more refined approach to this quantitative side because the pattern may turn out to be a differentiator between opera, operetta, Schlager, and other genres as well. Further research is warranted for these, as well as further data collection with more voice types and styles, COVID permitting, of course. And in addition, I have been in contact with the Voce Vista Video Pro team, including Bodo Maas, and exciting new developments to a vibrato measurement tool are currently underway. Finally, as a singer and pedagogue myself, I am particularly interested in the pedagogical applications of this quantifiable research work. I'm curious what the teaching implications for stable and variable genre appropriate and specific vibrato could be. So, to answer the question posed in the title of this presentation, does vibrato define genre or vice versa? The answer is obviously quite a bit more complicated than a binary, since vibrato, as we saw, is far from binary. Vibrato may not define genre per se, but vibrato certainly differentiates genre. I would like to acknowledge my research supervisor, Dr. Ian Howell from the New England Conservatory, where I'm currently pursuing my master's degree in vocal pedagogy, as well as Dr. Christian Herbst, who advised me while I began this project on my Fulbright grant in Austria last year. Thank you as well to NEC's Josh Gilbert and Kayla Gotero, who contributed greatly to this work. Here is my contact information on the right for you to get in touch with me. I'd love to hear from you. Thank you very much, and I look forward to discussing and synergizing with you soon.